So here we have problem 6.3 from our textbook, and we're given some information about some processes, and we're asked to predict the sign of the entropy change. So overall, we want to just boil it down to, is it a positive or negative change in entropy? Uh, so if we need a delta S of our system, or if we're rather looking for the delta S of our system, we can see that an increase in entropy, right, will give us a positive value, or a decrease in entropy will give us a negative value. So this is, again, only with respect to the system, not the total change in entropy that we looked at in a previous lecture. So let's take a look at example A here. So the delta S of this system is expected to be negative, right? So we would say that this is a negative delta S, a negative change in entropy. And this is because not only do we have 2 moles of reactant turning into 1 mole of product, we're also going from acyclic or linear reactants to a cyclic product. These are both consistent with a decrease in entropy. So a negative delta S for our system here. In example B, again, we expect this to be negative. The delta S of our system would be less than 0. We would see a decrease in entropy or chaos and disorder as we go from, again, an acyclic to a cyclic compound. So this is expected to show a negative delta S. All right, and then we have example C here. So this is the first time that we're going to see a positive change in entropy. And the reason for this is that we go from a more ordered cyclic compound, right? We have less degrees of freedom, less rotations of bonds and things of that nature. So when we go from a cyclic to acyclic structures, and then also 1 mole of reactant to 2 moles of product, both of these will contribute to the fact that there's a positive change in entropy, an increase in disorder of our system. D, our delta S system of D, is also supposed to be a positive change. And this is due to the fact that we have 1 mole of reactant, 1 molecule that is converted into 2 ions. So we have 1 mole of things over here and then 2 moles over here. So E, we will also see a negative change in entropy. So this would have a negative delta S associated with it. We're going from a 2 chemical entities, right? So we have 2 moles of things here between our substrate, our carbocation, and then our other reactant here. So we have 2 moles and they go into 1 mole here. So that's a decrease in disorder of that system. And then lastly, we'll go back and see another positive entropy change because our reactant is cyclic in structure and ordered, and then our product is converted into an acyclic compound. All right, so for all of these reasons that we discussed here, we saw either positive or negative changes in entropy. And we will look at question 6.4 next time.